I ended up removing all 5K networks from this board and did some more testing. In general, all the resistors have drifted up in value and the capacitors are off as well. So I do plan to fabricate replacements for all of them. In fact, I've even already done the K4 and wired it in. I also did some exploratory surgery on a couple of these. I was curious to see both how they were really wired up inside and try to determine what type of material was used. For example, this is that K4 module that was right in here. And this is how it was laid out inside. So capacitor, resistor, and this is how they were hooked up. So I did it exactly the same way. And just wired it up simply on the back like so. And I will do a similar approach on these other modules. As far as the material goes, the resistors sure all seem to be carbon composition. That's that black substance you see here. Capacitors are a little bit tougher to tell. I believe this is one. It seems to be some type of like white ceramic tube, but they could also be tightly coiled paper caps. I don't think they're mica though. So micas tend to be done in flat squares or rectangles rather than coiled up like that. The mica doesn't really, well, mica is a natural crystalline material and it doesn't really roll up, so I don't think they're mica. Which helped guide me in what components I chose to use. It also got me thinking about why did they use these in the first place. I can think of a few possibilities. For example, in modern circuitry, you might see these if they're really high frequency, because they can lay out precise, very small components on a little module like this and then seal them all up. Two could be for like RF shielding. If underneath this coating there was, say, a metal shield all around in here. Another possibility is thermal tracking, because this whole module will pretty much stay at the same temperature and all the components will be heated evenly. And finally, just to save space. These cabinets and predictors were pretty constrained for space, so mounting a few components vertically like so takes up less space than horizontally. Now this doesn't run at very high frequencies at all. You know, the vertical circuitry is at 30 hertz, the horizontal at a little under 16 kilohertz. So we're not talking about gigahertz here by any means. And I don't see any evidence of shielding on here. So I think it comes down to save space and, more importantly, thermal tracking. These modules were used in the horizontal and vertical circuitry, which tend to be a little touchy. And the components they had back then were not the greatest when it came to temperature stability. In other words, as the temperature changed, the values of the components would change. So I think that's the real key here. So that is what I'm going with in deciding what type of components to use. So I'm going to use metal film resistors across the board. They're very stable, plus I've got plenty on hand. That's what I've been using pretty much in all my restorations. And I'm going to go with half watt. These larger values, 150K, 33K, very unlikely there's a whole lot of current flowing through these, so I don't think there's much heat to dissipate. Which leaves us with the capacitors. For this guy, I used plastic film, just like I've used elsewhere. These are larger values, 2200 and 1500. And this one in particular hooks up right up to this guy, and they form a sort of AC voltage divider. And it was recommended online that you use the same identical cap for both. So, plastic film, stable with regards to temperature. I don't think I need super precise 1% accuracy on the values, so I think they'll be just fine. Now, I don't have the components I need to build up the others. Those should be here in a few days. I mostly, well, actually, I shouldn't say that. I did end up ordering a variety of components. We'll see how it works out. For the really small values, like say 82 picofarad, I'm going to go with mica. Very stable. And if money was no object, I would use mica across the board. But when you get to larger values, like for example, there's one capacitor that's going to be 8,000 picofarad. An 8,000 picofarad mica cap can be upwards of $20–30 if you could even find one. So that's getting a little crazy. So I think for the larger ones, I'll go with plastic film. For the really small ones, I'll go with mica. And for the in-between, I may use ceramic. I did order up some, I think p7o, also known as C0G, I believe, which are the types of ceramic that drift the least with temperature. So I'll use a little mix. We'll see how things work out. I think I'm just overthinking this. This is just a TV. It's not like an RF amp or anything. So I think it'll be all right. If not, we'll do a little experimenting. The internal structure on these modules is very straightforward because each one of these cylinders is just a discrete component. Not quite so simple on these. So I took one of them and I started to scrape away the external coating. And at first I was kind of confused because this is what's supposed to be inside there. 3 resistors, 3 capacitors. Well, I found one kind of metallic structure up here and what looks to be a carbon track running through here. And on the flip side, to be careful because this is cracked a bit. On the other side we see some more metallic structures. So what I deduced was these structures are the 3 capacitors. That seems fairly straightforward. Some metal on either side, insulator in between, you got yourself a capacitor. But this was puzzling. There was only one carbon patch for 3 resistors. Then I realized if I rearrange this schematic, all those resistors are connected in series, like so. So upon closer inspection I realized that this is all 3 resistors. And there's a tap here, there's a tap here, there's a tap here, and there's one at this end. So that gives you the 3 resistors, and here's the 3 caps. So I'm not entirely sure how I'm going to arrange it for my replica. I've been building them up like this with the components vertical, just like with these guys. This one, well, I guess I can replicate this structure, huh? Just have the resistors going horizontally instead of vertically, and then put the caps across the resistors like so. We'll see. I've got the resistors here, but I'm still waiting on these caps. I don't know exactly what the dimensions of them will be. I just thought it'd be interesting to show what's actually inside of these guys. Now that I have all the components I need to rebuild the K networks, I've been working at it. I think I showed this one earlier. That's the rebuilt K4 network already installed. I just finished rebuilding this, which is the K5 network, which installs right there. And right now I'm working on the K6 network, which is the one that installs over here. So far everything's going together pretty smoothly. As far as the parts I used, I decided to go with 1/2 watt metal film resistors. I decided that 1 watt was overkill. I'm using mica for the smallest capacitors, like 82 picofarad, 200 picofarad, 100 picofarad. And for the larger ones, like 3000 picofarad, I'm using a plastic film cap here. Now for this guy, notice I have much smaller capacitors on here. These are ceramic. I want ceramic for the in-between values, like 330, 1000, 1200, and yeah, even one of the larger ones, 3300. Figure if I'm going to use 3 ceramics on this, why not just go with all 4? And see how small they are. These are rated for 630 volts. So this is about the same as this guy. Plastic film, ceramic, almost the same capacitance and same voltage rating. Downside to these is they can drift with temperature, although I got the type that are not supposed to drift much, if at all. And there was another odd property they can exhibit, which is the capacitance can vary as the applied voltage across them varies, which can distort waveforms or cause problems. Keep my fingers crossed in this application they won't. Plus, from my autopsy, it looked to me like the originals were probably ceramic anyways. So I got a little bit of wiring to do on this. I've been going off my dissected diagram here of how the original was laid out, so I have my components laid out in exactly the same way. So 4.7K, the 47K, the 1000 picofarad, and so on, laid out in exactly the same order, and then it is wiring them up like so, and making little extension wires. I'll have to do a few more for these. Little ceramic caps don't have very long leads, so I'll have to make some extensions on those, and then I'll be able to pop that guy in there. I've been leaving the boards a little bit larger and then trimming them only after I'm done. Like here's the next one in line. See, I left the board full size, just in case I have to use some area up here. So, shouldn't take too much longer to finish these, and then I can finally reinstall the circuit board. I just have one network left to fabricate, and that is K3, the vertical integrator. Now this is the oddball one because it's got this thing, which is a combination resistor capacitor. So inside of this hybrid module, what I imagine they did is they laid down a carbon track for the resistor and then put a metal sheet above and below to make a capacitor resistor sandwich. Well, they don't make a modern equivalent to that, and I don't think I could fabricate one, not very accurately anyways, so see what I can come up with. So here's a somewhat different representation that corresponds to the 3 leads on the package. So 10K, 33K, 150 picofarad, 5000 picofarad. That's not a problem. This guy is. And here's another way to represent it with a resistor and a capacitor, which goes to ground. Now, if you look at other television schematics that don't use a hybrid module like this, you'll find the integrator is actually formed like this with discrete components. 2 resistors, 3 capacitors. So these two are equivalent. Now they say this is 90K and this is 4000 picofarad, so we could simply make these 45K and these be 1333 picofarad. The problem with that is those aren't standard values. It'd be nice if I could go with 3 resistors and 4 capacitors, and we could have 3 30K resistors, which is an available value, and 4 1000 picofarad caps, which is a standard value. But I don't think that will work quite right, so I'll stick with this. I've also heard some guys say you could use a 90K resistor and a 2000 picofarad cap on either side, but this is a traditional way to make a vertical integrator, so that's what I'm going to go with. So I did searching on Mauser Electronics, and I was able to find 16 and 1200 picofarad caps. So figure I'll go with 1 1600 and 2 1200s, total it up, you get 4000. Couldn't find 45K resistors, but I do have 47K resistors, which is pretty darn close. So this is what I'm going to go with. I've got my parts here, so see what I can cobble together on a piece of perf board. Here's how it turned out. Not too bad. The only thing I'm not happy with is that the best I could find for this 5000 picofarad cap was a 5100 picofarad, which is close enough, but it's a giant 2000 volt plastic film cap. Just couldn't find any little ceramic in that same value. Oh, should work out okay. Alright, so pop that in, and then I can remount this board, and there's still one more network to build that's underneath the chassis, which is this guy. It's used for suppressing the retrace line.